Hi everyone, welcome back to Java Full Stack Flow. Today's microservices interview question is, what is circuit breaker in microservices? This is a very important question for experienced Java and Spring Boot developers because circuit breaker is commonly used to improve the resilience and availability of microservices applications. So let's understand it step by step with a real-time example. What is circuit breaker? Circuit breaker is a fault tolerance design pattern used in microservices. Its main purpose is to prevent cascading failures. It monitors calls to a failing dependent service. When failures exceed a threshold, it stops calling the service and provides a fallback response. This improves system resilience and availability. Simple example, order service to payment service. If payment service is down, we don't want order service to keep calling repeatedly and waiting for timeouts. So circuit breaker protects order service from this situation. Next, how does circuit breaker work? Step number 1 is client sends request. Client sends a request to the order service. For example, user places an order and he wants to make payment. Step number 2 is order service calls payment service. Order service needs payment service to process the payment. The request goes through the circuit breaker. The flow is client to order service to circuit breaker, and then payment service. Next, step number 3 is payment service becomes slow or fails. Payment service may experience database problems, network problems, high traffic, service crash, timeout. Because of this, requests start failing. Next, step number 4 is circuit breaker monitors failures. Here, circuit breaker monitors the calls. It tracks failures according to its configured settings. Next, step number 5 is failures cross threshold. If failures cross the configured threshold, circuit breaker open the circuit. Next, step number 6 is fallback is executed. Instead of continuing to call payment service, circuit breaker executes the fallback. The client receives a controlled response. For example, payment service is temporarily unavailable, please try again later. This prevents unnecessary calls and avoids waiting for repeated timeouts. Now that we understand the basic working flow, let's understand three important states of a circuit breaker. There are three important states in circuit breaker: closed, open and off open. First is the closed state. This is the normal state. The service is considered healthy. Requests are allowed and the circuit breaker continues monitoring failures. Next is the open state. Here too many failures have been detected. So the circuit breaker stops calling the failing service. Instead, it immediately triggers the fallback response. But the circuit breaker doesn't stay open forever. After a configured wait duration, it wants to check whether the service has recovered. That's where the off open states comes in. Now we have the off open state. In this state, the circuit breaker allows a limited number of test requests to check whether the service has recovered. If the test requests succeed, the circuit breaker moves back to closed state. If they fail again, it moves back to the open state. So in a simple way, closed means call normally, open means stop calling, and off open means test whether the service has recovered. Now let's understand this with a real-time example. Imagine we have an e-commerce application. The customer places an order and the order service needs to call the payment service to process the payment. Initially, the payment service is healthy, so the payment request succeeds normally. But now imagine the payment service suddenly becomes slow or unavailable. When this happens, requests are start failing. The circuit breaker detects these failures. If the failures cross the configured threshold, the circuit breaker changes from closed to open state. Now it stops calling the payment service and immediately returns the fallback response. For example, payment service is temporarily unavailable. Please try again later. This prevents the application from continuously calling the unavailable payment service. Now that we understand the concept and real-time example, let's see how we implement circuit breaker in Spring Boot. In Spring Boot, we commonly use Resilience4j to implement the circuit breaker pattern. For example, we can use the @circuit breaker annotation. Please check example code here. The @circuit breaker annotation tells Resilience4j to apply circuit breaker behavior to this method. The name identifies our circuit breaker configuration, and fallback method tells Resilience4j which method should be called when the fallback needs executed. The fallback method can return an alternative response such as payment service is temporarily unavailable, please try again later. So instead of continuously calling the failing service, our application can gracefully handle the failure. Now let's finish with an interview ready answer. If the interviewer asks what is circuit breaker in microservices, so you can answer like this. Circuit breaker is a fault tolerance pattern that prevents repeated calls to a failed or unavailable microservice. In Spring Boot, it is commonly implemented using Resilience4j. When a failure exceeds a configured threshold, the circuit breaker changes closed to open and stops calling the failing service. Instead, it returns a fallback response. After a configured wait duration, it moves to off open state and allows limited test requests. If the service recovers, it goes back to closed state. Otherwise, it returns to open state. This helps prevent cascading failures and improves system resilience and availability. That's all about circuit breaker pattern in microservices. If you found this video is helpful, please subscribe my YouTube channel and follow me on Instagram for more microservices interview questions. Thank you.